So this is number 4, model validation. For this, we're going to use that EPC case and then the West example one with the DYD. So if you get a chance, you can load that one up. The idea on model validation is when you do a transient stability run, you're working with the model, and WECC is working on getting this better and better, so hopefully this will eventually go away. But so far, it has not been uncommon for cases to have what we might call errors in them. And sometimes the errors are subtle, sometimes they're not subtle. So you need to do some sort of validation, and the term error should be kind of in quotes because if you have small time constants, those might not be an error. They might be really representing how the model responds, but they will cause numerical instability, so we treat them as they weren't good, so they need to be fixed, so they're an error. Simulator allows you to do this validation automatically and lets you see what's going on when you do it. The main validation checks are it checks for time constant issues, it checks for machine parameter issues, and it checks for limit consistency.
So how do you figure out the time constant to begin with? I mean, do you have a random number between like 2 to 4 or something like that?
Well, the time constants come from the model, so we're not figuring them out. We're just taking what comes in the model, and then we're looking and saying, is that value okay? And usually we're concerned about very small time constants that would cause numerical instability. Kind of our philosophy is for the most part, the user is going to be, we're assuming the user is put in good data, unless proven otherwise. I mean, we do some checking to see if parameters are within normal ranges, but normally, sometimes you have ones that are outside of normal ranges and they're still representing the device correctly. So there is some give and take on this. If you would like, why don't you load in the WECC case and then load in it from the EPC and then go ahead and load the DYD. If you already had the case in there, you probably want to reload it because when you ran it, it auto-corrected the errors, and we kind of want to go through the errors right now.
Was that the last example again?
Yeah, so I'll go through it here. In Power World, I went to the option to load the case, and I selected the GE EPC format. I'm going to load the West example EPC. If it asks you to save the existing case, just say no. Yeah. Another way to load transient stability cases, what I showed you is file, load transient stability data, and that's a fine way to do it. The way I usually do it is under the add-ons transient stability, there's stability case info up here, transient stability case info. You can get to the case information, models in use, generator model use, load model use, model supported status, the summary displays we talked about before. You can also load a transient stability data. Either way is fine. I just tend to use this approach, but they do the same thing. So I'm loading the GE DYD data, West example DYD, open up. Okay, so then if we go to the case here, add-ons, transient stability. Over here, go down to the validation tab. usually you will seldom go to this display on your own because PowerWorld, when you click Run Transient Stability, it will automatically run a validation on the case. So you cannot run a case without having some validation run on it, because we don't want the bad stuff coming into the case. We do have an option here, unsupplied models. If you run a case with a model that PowerWorld doesn't support, we give options for what to do about it. This is less and less and less of an issue because we support just about everything now. But if you ran one and the model wasn't supported, we would want to let you know about that because your results aren't going to be what you expect. So we, by default, have it raise an error which just says that model's not supported. You can, then you can either disable the model or you can say, don't give me an error, I know about it already.
So for wet cases, there's the approved model list from MDWG, and so PowerWorld Simulator supports all of the approved models, and so in theory, any wet case should not have a problem with the model.
So if a new model is created, what's the process for you guys to get it into your quiver, whatever you want to call it?
So at least in the WEC realm with modeling validation work group, and PowerWorld staff attends and participates in that group.
Okay.
Yeah, with WCC, we're very involved in it. With other places, there's less of a formal process for doing that, like on the Eastern Interconnect. You guys are well coordinated. The way to validate a case, if you want to find out are there issues with it, is to say run validation. So go ahead and click on run validation. And in this case, this is not a new model. This is an old model. It gives you quite a few issues associated with this case. In fact, it says there's 2844 errors with the case. Now, just because it's saying a lot of errors doesn't mean that they're really errors per se, because if you have a very small time constant, like I said, just because we can't handle it, nor can other integration methods, and we're going to fix it, it's not an erroneous value. It just isn't compatible with the software. We won't do it now, but the easy way to get rid of all these is to click Run Auto Correction, and it'll correct them all. So we're not going to do that just yet. A key parameter here is minimum time constant size as a multiple of the time step. This value says for a lot of time constants, you take the time step that you specified on the simulation page, multiply it by that, and that is the minimum value for that time constant. So if I go to the simulation page, we're running here at a half cycle. That's what this case was set up for. WCC standard is a quarter cycle. So why don't you go ahead and change that to a quarter cycle. And then go back to the validation page. We had 2844 errors. Click on Run Validation again, and we'll see what happened. All but 10 of them went away. The reason why is that this case was tuned for a quarter cycle by somebody. Somebody went through and set those time constants so they work at a quarter cycle. At a half cycle, you get these violations. Is a quarter cycle better than a half cycle? Well, PowerWorld tends to be numerically stable with WCC cases at a half cycle, but people want to run a quarter cycle. The cases are tuned for a quarter cycle, so as long as you run it with the time step that it's tuned for, you shouldn't have many problems. But it is an important point that these time constants are based on your time step. All right, so we'll get to fixing them in a little bit, the ones that aren't fixed already. So why might there be some issues here? Limits on time constants. This here, if you're not familiar with block diagrams, and like I said, I wasn't really familiar with them before I got into this, this is just saying the input coming into this block is integrated with a 1 over t multiplier on the integration. If that goes to 0, a 1 over t multiplier, as t goes to 0, it goes to infinity. So clearly, this one cannot be ignored. Okay, and t can't be too small. Okay, so there has to be some limit on that. It says it must be greater than the specified multiple of the time step, and it can't be 0. So we don't allow 0 on that. In contrast, a 1 over 1 plus st, that's a filter block. It sort of models a measurement delay. And on a block like that, if you put an input into a block like that, where you put an input like that, the response on that will just be a delay like that, just a first order rise, like a RL circuit. This would model a measurement time delay. You know, let's say your voltage changes suddenly. There's going to be a little bit of a time delay in sensing that, and this is proportional to the time value there. If it responds instantaneously, t would go to 0. This is one where if t goes to 0, we just sort of ignore this. It just becomes input is equal to the output. Okay, so it's saying that time constant goes to 0. As that time constant gets shorter and shorter, this rise time gets closer and closer to matching that unit step. So in this case, if you enter a value of 0, that's fine. We just, in the code, we know how to ignore that. It just becomes what we call an ignored state. But if you try to put t too small, but not 0, it gets into this forbidden region. So we have a forbidden region, as does PSLF. And we auto-correct it. If it's close enough to 0, we treat it as 0. If it's close enough to this 1 over, or if it's close enough to 4 times the time step, we just up it to that. Another common block is what's called the lead-lag block. These are common on some exciters and stabilizers. If you have T2 equal to 0, that actually is not physically realizable. If I put T2 equal to 0, it would be saying I'm inputting the input plus its derivative. And actually, we cannot figure out what a function's derivative is instantaneously. It's non-causal is what it is. So we have requirements that T2 cannot be too small if T1 is not equal to 0. If T1 is equal to 0, then this one just becomes that one, and it's okay. Okay, so there's limit checking that's going on in there. A common way for inputting data, a lot of times you see T1 and T2 non-zero and equal. In that case, they just cancel out, and it just looks like a unity gain. So there's no problem with that. Synchronous machine reactance validation. This can get kind of tricky, but there are some relationships that have to hold on synchronous machines. The leakage reactance, this is physically derivable from the models because synchronous machines involve inductances, which in 60 hertz become reactances. The leakage reactance has to be smaller than the subtransient reactance, which has to be smaller than the transient reactance, which has to be smaller than or equal to the synchronous reactance. So we have these relationships that are required here. Sometimes we see cases where these relationships are violated. And then the question is, what do you do? And for the most part, we mimic what PSLF does. And it's questionable on some of it because you're auto-creating data and you're trying to figure out what the user intent is. And it's probably an error, but if you give people too many errors, it becomes a problem as well. So there is sort of a, if you auto-correct stuff too well, then the modelers that are debugging the case won't pick up on it because they won't see it as errors. So, I mean, there's trade-offs that go on in this. So the auto-correction that PowerWorld goes through are these relationships right here, which have something to do with physics but are clearly arbitrary as well. You know, the best is that you don't have to do this, but we are seeing data occasionally where this has to be done. But you know, I'm not up to date on the latest of latest cases, so it could be all fixed.
So if this duplicates, at least this part, with the transient subtransient reactances, if it duplicates what PSLF does, in theory, the posted wet cases, there's 2 folders for each case. One folder ends with an E, and they're exporting to EPC format for the data, and they are exporting the DYD format after the fixed bad data is clicked in PSLF. And so in theory, we shouldn't be getting these when we bring in that DYD file that was downloaded from the WEC website. But I still see this even with those files, so I don't think all that's getting saved in the DYD file after that PSLF fixed bad data is cleared.
Yeah, I don't know when they save it or not.
So Gordon, you're saying the E files they have, basically they run the thing in PSLF, right?
Yes. So they run, they click the fixed bad data for the DYD data, and then they're supposed to, then they export that, and that DYD file is in that folder, that case folder that starts with an E, which has the EPC format for the base case. The other folder has the binary save format,
Right.
and that DYD file doesn't have this fixed bad data applied. At least that was what I was told, and that they're getting that from the master dynamics file, which has all of the comments in there about all the data that was historically submitted and corrected, and who did it, who submitted the correction, that kind of thing. Yeah, so your best bet, though, is the EPC and the DYD file that's in the folder that ends with an E on any case.
Yeah, and I will say in PowerWorld, when you run auto-correction, it does change the value. And we could have set it so that the value stays same on the PowerFlow side and just what's shipped over to transient stability is changed. That maybe PSLF is doing that, I don't know. But we changed the value. So once it's changed, it's changed. So, I mean, that's just a design philosophy.
Do you have these auto-correction rules documented anywhere else except for the documented representation? Like in the program itself, maybe?
I don't think so. I think it's all kind of embedded. That's probably something we need to pull out and make it very explicit what we're doing.
Yeah, I mean, we've got them here. I don't know where else. I mean, you see them in the log, and we're going to see this in just a second.
In your help files and stuff? Oh.
I don't think so.
So will it autocorrect if it doesn't meet the initial, I mean, if the, say XD is just a teeny bit less than XD prime or whatever, it's not the 80%, will it autocorrect it to 80% or not?
No.
It would leave it the higher value of what it was, okay.
Right. If you put that to 99% of XD, the assumption is the user knows what they're doing.
Okay.
Okay. Because, I mean, maybe the machine's like that. And it's only if it's greater than, because there are some machines where you set you set these two equal, and that changes how the machine's modeled, and that's a valid condition. So this is a strict greater than sign. Yeah. Limit consistency, the min limits must be less than or equal to the max limits. That's they're flipped when you do that, when you run autocorrect. Initial limit violations are also indicated and handled using these validation tools. That's an option on how you want to handle initial limit violations, but in that case, the initial limit violations are case dependent, so what's in the saved case isn't changed. Okay, it's just what's run in the transient is changed. Like that example where we talked about with the VR on an exciter. VR is a calculated state. If it's above its limit, there's an option that it'll automatically change the limit, but that's just a temporary change. Because the next case you run, the VR might be different. It might be below its limit. Some limit pairs must surround 0. Like the limits on a stabilizer output, you have to have in steady state, a stabilizer output is going to be 0. You have to bracket 0. So we check for that. If we can't fix it, we can't fix it. Limits on the derivative of a state have to be, derivative must be 0 at steady state. Governors have those types of limits. In steady state, for example, on a hydro governor, if you're looking at how fast is the valve changing its rate, it can't be changing in steady state, because that's not steady state. Some limit pairs are specified by a single number, and the limitation is plus minus of that limit. So we talked about the time constants and model that PowerWorld can read. If the model can read is not supported, this may list an error. That's getting less and less because we support practically everything now. Sometimes generators don't have a machine model. That's not an error. That's just treated as a warning. So this is on the warnings. Generators may be connected to buses with 0 voltage, so it's connected to a dead bus. That's okay. Parameters may be outside their expected range. That is not an error. The expected range may not cover all situations, so we don't want to call it an error because maybe you really want it outside of that range. And then what does simulator do if there's no machine model? As I said before, if the model is not there or is inactive, it ignores everything else, treats it as a constant current based on the initial condition, goes back and then calculates an impedance based on the PQ values. No special command to ask for that. That's just done. So it's netting it just like in PSLF. Okay, there's some informational messages that I don't tend to look at a lot. When you do auto-correction, you will see informational messages. They'll tell you what was auto-corrected. We also allow you to use different time constants. You can increase the multiple of the time step or set it to 0 if it's allowed to. So on this page here, this is a minimum time constant. It's 4 by default. You can change that if you want to run smaller time constants. Okay, so it's sort of up to you. So if we look at what this case picked up for, there is one where XL is too high. There's one where, another one we check is XQ double prime. If it's too different from XD double prime, that's an error. 2 more on XL. There's one on XQ being too large. Here's one where R open is not allowed, less than 0. These are rate limits. Here's another XL one, and then there's some time constants on some governors there.
So what happens if you have a way too big time constant? If that's an error.
If it's too big?
Yeah.
You mean you put in too big a time constant?
Yeah.
Well, if you put in a time constant going to infinity, you would just get a flat value there.
I don't infinity. I'm talking way too big, outside the normal range. Okay, so.
Well, we let you do it. We don't restrict it. I mean, when we go through this, we have to decide, how much do we nag people about stuff or not? Because if you nag people too much, then they just totally ignore everything. So what we do give you is, which, I think is kind of a unique aspect of Power World. If we go back to where we were before, stability case information, and I look like the models in use, and we talked about this before. Let me right-click on GenRU, show dialog, and let me go over to, let's say TD0 prime. All right, so here is TD0 prime, just some generator parameter. This generator has it as 1.2. That's the minimum value. Okay, so I click the other way. The maximum value in this set is 15. Is that right or wrong? You can even plot them. If I right-click on here, plot column. I wish plotting did not default to blue, but it does. Seems like. Was that just luck of the draw? There is the spectrum of TD0 prime across our generator count. So do I say, some of them go to 0 because that's a condition for a salient pole generator. But do I say this is a valid range? If somebody puts in 80 for that, is that right or wrong? Probably wrong, but maybe it's right. But you can get access for that. So if you're seeing something that's behaving strangely, you can look at all the models of that type and you look and say, is this an outlier? And I do that a lot. When we see strange behavior, I'll look and I'll say, is this an outlier compared to what the rest of them are doing? And we let you see all the model parameters in the case real quickly. Okay, so then if we go back to this, go ahead and click autocorrect. And we set it up so when you click autocorrect, it corrects everything and it goes to the warning page. So now we have 0 errors and 47 warnings. And here it's saying, here's a bunch of generators that I don't have models for. Generator does not have a machine model defined. That's just a warning because it might be a small generator and maybe you didn't want a machine model for it. Here's a couple of the sort of nag messages on some of the T values. TD0 prime greater than 5 times TD double prime is recommended, but the user is assumed to be in command. There's another one, not defined model. Motor model has 0 megawatts. That's just a warning. And then in the information messages, it tells you what we did to fix the errors that we had before. So it provides you a detail on the fix that was applied. And all this can be exported into Excel or whatever you want to do with it. Most people will do the run, just save the case and run it, and the errors are forgotten. I did want to comment on the idea of validation. The word validation is used in different ways. This is not validating Power World versus some other package. That's not done automatically. But we have developed many ways to automate that process. This is more University of Illinois. We're getting some tools to BPA that can help in doing that sort of analysis. But it's the bottom line is PSLF and Power World match pretty closely.
Quick one. You said if you don't go through this process manually, if you just click run transient, it'll go ahead and automatically do this.
Yep.
Correct?
Well, it will run validation. It will not run autocorrect.
Oh, okay.
Yeah, it won't autocorrect for you. It will run validation for you. Yeah, we didn't want to autocorrect stuff, but usually once you run a case, you autocorrect it and you save it, it's autocorrected and you'll never see it again. So that becomes more of an issue as you have multiple contingencies defined for a case and then do multiple processing on a case.